everyone. So we have a good question from the chapter of simple harmonic motion, and this particular type of question is called angular SHM. All right. Why? Because in order to get the equation of SHM and to find the details about it, we will be using this particular formula. T is equal to I alpha. Okay. So let's begin. So I've drawn a picture of I've basically copied this diagram, okay, and I've also, what I've tried to show is that I've tilted it slightly with a small angle theta, and now we are going to basically draw the diagram, okay, and we are going to try to equate all the forces, okay. So as you can see, since I've tilted um, this spring is slightly stretched. This spring right here is slightly stretched, right? So it is basically getting a force. It's basically trying to, try to uh, lessen the stretch, right? It's trying to get itself compressed, right? So we will have a force in this direction. Okay. Again, for this particular spring, you can see that it is compressed, right? So it wants to be stretched. It wants to go back to its natural length, right? So um, okay. So it's giving a force towards this side, right? Now, a mass M has been attached at the bottom of this rod, and yeah, it's basically pulling this entire board, trying to pull it downwards, okay, trying to make this thing move in the anti-clockwise direction, trying to move this system in the anti-clockwise direction. And yeah, so are these two springs. It's basically trying to move it in the anti-clockwise direction, right? And we have got the mass of the body here. So this is, let this be the center of mass of the body, and we've got the gravitational force for this body acting as well. Let's call it this m dash g. And this thing, this component of mg is also trying to make this body rotate in an anti-clockwise direction. Okay. So let's now write the equation. Tau is equal to I alpha. Okay. So let's first deal with this particular spring. Okay. First, let's deal with this. So uh, if this is the spring, so say, okay, and we have got the rod at this particular angle. Okay. This particular length is b, right? That is what has been stated. So, and also one more information which I missed out, this angle is theta, right? So this particular length, which is what we need, if the force is in this direction, we need the vertical component of the length, right? The length component of the length, which is at 90 degrees with the component of the force. So this length will basically be b theta. Okay, this is assuming that the theta is very small. That is when angular SHMs take place. Okay, all right. So yeah, k b theta, and if you see, this spring has been stretched for an angle. So let's now work on the torque equation. Okay, tau is equal to I alpha. Now let's deal with this first spring over here, which I have already highlighted. Let me draw this separately so that I can explain how everything is working. Okay. Suppose this is the rod, okay, and this is the angle theta, right? This length right here is b. So this this length is basically b theta, right? And this is also the length by which the spring has been stretched. Okay, and this particular length the vertical component of the length is b cos theta, right? So let's write the torque now for the first spring, which is k x. Kx is the force, right? The x is b theta, and now we will find the perpendicular distance from the pivoted point, that is b cos theta, right? Okay. Now let's deal with the second spring. The second spring, the same thing will happen, just replace b with a. So that will be k a theta a cos theta. Okay, the same thing basically will happen. Now let's work with the mass. Let's work with this lower mass first, this mass. Okay, let's work with this first. So if this is the rod, this is the pivoted point, this is mass m. Okay, the force is vertically downwards, right? So we need to find this component of length, this component of length. This angle is theta, this angle is L. So this particular, this length will be L sine theta. Okay. So the component of torque, or the torque because of this mass, will be mg L sine theta. Now there is also a force which is acting because of the mass of the rod, right? Because of this, mg, right? So for this, the perpendicular component of length will be this amount, right? This much length, and that length will be L by 2 sine theta. Okay, so this will be mg L by 2 sine theta. Now, like I have told you before, all of these forces are trying to make uh, this particular rod move in the anti-clockwise direction, right? So all of them will have the same sign. I consider that to be plus. Okay, not I consider, I mean, if you take the cross product here, okay, say the formula for torque is R cross L, right? So if you will find that the torque, all the torques are in the same direction. Okay, all of them are in the same direction, and I consider that direction to be positive, and yeah, I have it over here. So this thing will be equal to I into alpha. Now the moment of inertia of a rod when it is attached at one end will be ml square by 3, right? ml square by 3. And we have also got one piece of mass attached over here, right? So the moment of inertia because of that is ml square. Okay, so this is multiplied by alpha. Let's now add everything, but before doing that we have taken a few assumptions, right? The assumption is theta is almost 0 degrees, it's very small. So as you can see, if we take this particular assumption, we will get this cos theta will be 1, this cos theta will be 1, all the cos thetas will be 1, and all the sine thetas at a very small angle. What we can do is we can convert this to theta, right? At theta, when theta tends to 0, sine theta basically becomes theta. Okay, so let's now place all the values. This will be kb square theta plus k a square theta plus mgl theta plus mgl by 2 theta. This will be equal to 4 ml. Okay, yeah, and let's add everything up now. this will be k b square plus a square theta plus 3 mg L by 2 theta is equal to 4 ml square by 3 alpha. Okay, now we will be putting the values of B and A. So I think B and A are L by 2 and L by 4 respectively. So I'll just put all the values over here. So this will be K, not capital L, small l, okay, small l square by 16 plus L square by 4 plus 3 mg L by 2, this entire thing into theta into 3 by 4 ml square, right? This is equal to alpha. So alpha is proportional to theta, right? And we have got alpha is proportional to theta. Alpha is proportional to theta. Okay. And that proportionality constant, which is this, will now become the angular frequency, right? This will become the angular frequency. Okay. So the angular frequency is equal to 3 by 4 ml square k square 16 5l square into 5k square l square plus 3 mg L by 2. Yeah, that's it. And we have been asked to find the frequency, right? So the frequency, f is equal to omega by 2 pi, right? So we will just put the omega over here. Yeah. So this will be 1 by 2 pi under root of 3 mgl by 2 plus 5 k L square by 16 divided by 4 ml square by 3. Okay. And I apologize here. This entire thing will be under root. Okay. Yeah. And there you have it. This entire thing is the frequency of this equation. Okay. So this is whenever you get such a complicated question, try to break it into parts and simplify the entire question. Okay. Just stick to your basics and everything should be all right. Thank you.